Hello everyone. Today we are in the linked list section of data structure. In this section, first we will discuss what is the linked list. A linked list is a data structure consisting of groups of nodes which together represents a sequence under a simplest form, and each node is composed of data and references with other words and links to the next sequence. That means if you have a node A here and A is connected with B, B is connected with C, and C is so on. That's why they are creating links from A to B, B to C, and so on. Those are known as linked list. By this figure, you can easily understand what I am saying. The name of star is here, and each and every link of nodes is connected with other by linking. That is why it is known as linked list. Here we have 5 nodes which are connected with the link. Here those pointers are for the next pointer of the third node, and this section is for the informational part. That means this first section, which is situated in the left section, contains the information, and this point contains the pointer value of the next pointer. In this section we have declared for this third node, so we have declared the third section here. Representation of linked list in memory. The representation of linked list in memory we can understand by such as info k and link k contents. We will choose null equals to 0 unless or otherwise the linked list is started. In this section we have information, which is info, and link, which is link. Here we have started from 1, 2, 3, 4, 5, 6 up till some points. In this section we can see that here the link index number 3 is connected with the information number 3 which is indexed, and in 6 this is connected with the info 6th position, and the number 9 is connected with the start position. That is how information and links are connected. This is the representation of linked list in memory. This diagram is important for examination. Traversing a linked list means to visit the points of the linked list. Points means always the nodes. Here we have declared a PTR equals to link PTR. PTR is the pointer here, and we need to visit the link PTR. If the PTR value is 0, we need to visit the link 0, which is this one. Then if it is 1, we need to visit this one, 2 for this, and 3 for this. That is how we visited or traversed the linked list. Algorithm of linked list is given here. First we need to start the position and then repeat 3 and 4 until the PTR is null. Apply the process information of PTR and set PTR equals to link PTR. That means PTR is now pointing to the next index. That means if it is visiting the 0th index, it will indexing to the index number 1. When it is visiting the 1 index, it is pointing to the 2. And when the PTR is not equals to null, this will repeat the condition 3 and 4, and after it will exit the loop. That is how the linked list works. Insertion from a linked list is given here. In this list section we have info, link, start, and avail. Start is the starting position, avail is the available index, link is the linking section, and info is the informational part. Here we have start, which is the starting position, and before insertion every node is connected with each other. Here we have node A and node B, and this is the final one. This is known before insertion. After insertion, we can have from here that we are in the starting position and we are going on, but in the middle of node A and node B, we have an other insertion section which is needed to be added like this one. So this picture is for before insertion and this is after insertion between node A and node B. All other things will be remain same. In this section, we will free the free storage section and data list section. Here we are doing the same thing with different diagram. Now we are adding in at the end of node A, we are pointing to the node N, which is available here. That is why it is called avail. Then which is connected to the so on section till the end. But here this pointer is also connected with node B. That is how it works. Start from here and goes to node A, then node N, and then again returns to node B to the end. The description of algorithm is given here. You can have a snap of this one. Remove the first node from the avail list means we are connecting here. That's why we are removing the first node from the avail list. Info new item is the item and link new is the starting section. Last we have start equals to new and then exit. Deletion from an array linked list is given here. Here we have node A, node N and node B. We need to delete the node N, which is the before deletion. After deletion, this link will be directly connected to the B, skipping the N section. That is done here. This node A is directly connected with node B, skipping the node N. That is the condition after deletion in linked list. Observe the 3-point fields are chosen here. You can go through them. Here available now points be deleted on node N. This deletion of linked list can be delete as like as this also. Here in this section you can see that we have not directly connected with everyone. In this node A section the available is connected and the pointer is connected to this one, which is the free storage list. The advantages of linked list is given here. Linked list can grow and shrink by the runtime and queues can be easily executed. Deletion and insertion is easier than other. There are some disadvantages of linked list. No element can be accessed randomly because you go with the sequence from 0 to so on, but in array you can easily access to any element. Have a snap of the disadvantages of linked list and advantages also. That's for today. Thank you.